looks like we're good to go.
All yours.
All right, thank you. Alrighty, so welcome. Thank you for taking the time out of your day to come to our HeatSmart webinar. Before we start, I just want to introduce the people on the call. There's Adam Flint, our Director of Clean Energy Programs. Haley Delisle will be on soon too, our Campaign Director. I am Eleanor Colton. I'm the Lead Energy Core Intern. And we also have Olivia Price, one of our other interns, as well as our installer partner, Ryan Dailey. So Olivia, if you could just go to the next slide, thanks. I want to let you know before we begin, we do have a few more webinars happening this month and next month. So if you have any more questions, if you're looking into more things, those are available to sign up on our website as well as on our social media. Next slide, please. All right, so like I said, my name's Eleanor Colton and I'm an Energy Core Intern at HeatSmart Southern Tier. HeatSmart is a program of NEST, the Network for a Sustainable Tomorrow, which is a nonprofit located in Binghamton that works with community partners to generate social, environmental, and economic well-being in the greater Binghamton area. Next slide, please. So today we're going to go over what is HeatSmart Southern Tier, why choose HeatSmart. I'm going to introduce our installer partner, Dailey Electric and Geothermal. We're going to go through a quick case study. Well, not quick, but we're going to go through a case study. We're going to talk about incentives and financing, how to participate, and then we'll have time for your questions at the end. While we're going through, we do have people in the chat to look for questions if you have them. So go ahead and pop them in there or wait till the end. Yes, and at the end, we will send out a link to the recording and to the deck. So what is HeatSmart Southern Tier? So HeatSmart is a NYSERDA-funded community outreach program that connects you to local heating and cooling and energy efficiency experts who offer the latest clean energy technologies. We work to educate the public about sustainable heating and cooling systems and things like these webinars, tabling events, when we could have them, and other things like that. HeatSmart operates in Broome, Tioga, Shenango, and Delaware counties and is one of several pilot campaigns for NYSERDA. NYSERDA supports communities across New York State in implementing these community-based outreach and education campaigns for clean heating and cooling. If you want to go to the next slide, please. So some of the benefits of HeatSmart Southern Tier that we work to reduce energy costs, we improve home comfort and safety, reduce your greenhouse gas emissions, and increase community awareness about these green energy technologies. Next slide, please. Right now, New York State's main sources of greenhouse gases are, as you see, transportation is huge, and buildings are actually the second biggest source of emissions in New York State. So this is one of the things that we try to reduce. 90% of New York households actually use fossil fuels for their home heating. So that's something we're working on. Next slide, please. The HeatSmart program covers weatherization and then 3 kinds of heat pumps. You've got ground source, air source, and water heater pumps. Next slide, please. Oh, sorry. At HeatSmart, we are partnered with energy-saving installers to implement these programs. Our partners are AirSource LLC for air source heat pumps, Dailey Geothermal for ground source, and the Insulation Man for home performance and efficiency. And then in Delaware County, we also work with D&D Refrigeration. Next slide, please. Now I'm going to turn it over to Ryan Dailey at Dailey Electric and Geothermal to talk about his work.
Hello, everyone. My name's Ryan Dailey. I've got to shut this off. Look, this thing's messed up. I'm sorry. I'm getting that echo. What do I do?
We can hear you just fine.
Okay.
But if that's your phone, you can just go ahead and mute your phone.
It says muted.
You're still getting that echo?
Yeah.
Okay. Well, we can hear you fine. So if you want to hang up on the phone connection, I think we'll be okay.
Okay. Should be done. Sorry. Thanks. Hi everybody. Sorry about that. I own Dailey Electric in Penn, New York. We're a small business that specializes mainly in ground source geothermal. We also do residential plumbing and electric. We have currently 22 employees that do almost all geothermal and then residential electric and plumbing. We do a small amount of air source heat pumps locally, but mostly all geothermal. I've been part of the HeatSmart program down in Binghamton for a couple years since they started, and also part of the Tompkins County one. And it's been a very good program, and hope to see it spread much more across state. So I guess our business, going back to our business, my dad started it, and my wife works here. My mom and my dad both still work for the business. It's pretty small and basically allows us to keep control of most things a little bit better if we were to get huge, which we don't want to. So it lets us really concentrate more on geothermal and what we want to do, which is install more geo. So I guess what we have here is we're going to do a case study on a house we did. And did you want me to explain the heat pump side like this, or do you want to move right to the slide?
We've got a few slides of just basic, like what is heat pumps, a little bit of background. So if you want to explain as we go through those and then dive into the case study, that'd be great.
Okay. I mean, a heat pump is a very, very simple technology. It goes along with exactly what Adam Flint says all the time, is that everybody has when it's a refrigerator in your home, is the exact same thing as a geothermal heat pump. And I always just say, instead of plugging it into the wall, you're plugging it into the ground. Basically, it's a refrigeration process. You either bring air back across the coil, or you're bringing water back in water-to-water units. Different compressors now do different things to allow us to have higher water temperatures, and everything now is variable in the forced air side, mainly what we do. And voila, it's magic heat, as everybody likes to say it is, but it's really not. It's pretty simple, straightforward. It's the same as air source that Dave does. He uses air, we use a fluid. So it's a pretty simple technology that's been around for a very long time. Next. All right. So there you go. We have ground source heat pumps, we have air source heat pumps, and then we have heat pump hot water heaters. Ground source doing whole homes, radiant, lots of applications, greenhouses, anything you can think of, you can do with ground source for the most part. 100% production of hot water. Lets you do all kinds of things. You have VRF. You have all kinds of, you have unlimited options with the ground source. Air source, same thing, whole house functions, no problem. You can zone different rooms. You can do anything you can think of. I believe there are some situations now commercially that are producing hot water. Well, we'd have to ask Dave a little bit more on that, but air source is still very, very good technology. And there's a lot of applications where ground source can't be done, air source can be done. And there's a lot of applications where air source isn't the answer and ground source could be. As far as the heat pump hot water heaters, same thing. It's a small heat pump on top of a hot water tank. Becomes very efficient. It cools your basement a little bit by taking the air running across the heat pump. It's using your basement utility room, whatever you may have to produce the hot water. Some of the colder months ends up using a little bit of electric to boost it up, but still a very good technology to produce your hot water very cheaply and efficiently. So there's our types of ground source heat pumps, I believe, for this. So we're going to talk about horizontal, vertical. Horizontal, you dig trenches out. You can do them all kinds of ways. Slinkies, you can do raceways, you can do single trenches. There's a multitude of ways to dig the loops, depending on how much space you have and how much disruption to the yard you want to have. A vertical, come out, drill down a hole, and it's tied back into the same feeder that you would generally see in a horizontal system. Majority of systems can be done on a single borehole. Either grouted thermally, it's a different size pipe we use. There's different ways to do it. As soon as we get over a certain tonnage, we'll have multiple holes. And the vertical situation is generally less acreage is needed to do it. You also have open loop situations, and you have lakes and ponds and all kinds of other applications for loop fields for geothermal, but horizontal and vertical being the most common. So that is a water furnace 7 series, I believe. That is the best unit you can pretty much buy. It replaces a furnace or air handler or whatever you may have inside your house. It should have easily a 20-25 year lifespan. You can fully eliminate any of your fossil fuels, and that one has a desuperheater. You can see right on the side there has a small desuperheater setup that's not hooked up, but that could produce some of your hot water, and not all of it, but it could produce quite a bit for you. Okay, so this is a case study we did a while ago, and it is on a 7 series like that unit you just saw there. This customer's name is Steve Culver up here. Actually, it's in Penn Yan. That is Steve's house, built in, actually, if you want to flip to the next slide, I can tell a little bit more. It's kind of a basic, there you go. So his house was built in 1953, just over 2,200 square foot. The attached garage, he ended up finishing off and making into a store kind of for selling bait. He's big into fishing. 3 bedrooms, 3 baths, basement's half finished. He sits on 4 acres of relatively flat land, and that is the system that he had. We actually put that in for him 15, 18 years ago. An outdoor wood burner. The house had a real old oil-fired boiler or furnace in the basement, terrible duct system. It was just a convoluted mess basically in his basement, and he was done cutting wood. Had enough. So that's why he'd had enough. He's done with the wood cutting, wanted to fish. So now that's all he does, because he doesn't have to spend 3/4 of the year cutting wood. We should have had that at the end. So that's Stevie's layout of his house. You can see the kitchen has a full wing. The kitchen in that living room area was very poorly insulated. The windows are not very well down there. The bedroom main area there actually has a bathroom right in the center of that. You see the square box located there? That is roughly where the Geo unit is located underneath. The existing furnace is all the way to the other end underneath that kitchen living room. It's all the way, I guess we'll call that the right-hand side. It's the south end. And so I wanted to move it to the middle to try to balance out the duct system and get a little better heat. Then in that sitting room, actually the kitchen living room area has a finished part of the basement, and then the bedroom part has a finished part. The sitting room sits underneath a dirt crawl space. The entry is on a slab that goes into the garage on a slab. And then his master bedroom was a wing that is also on a slab with no access to it, but he gutted it and had a really good insulated, and there's like an office split in half the bedroom. The trick was getting ducts out to there because there was baseboard in that room, baseboard hot water. So getting ductwork out there was quite a trick, but that's the basic layout of his house. So that's the south end of the house where the old unit sat. The whole duct system needed to be redone because it was just horrible. There was a hot water coil on the unit. There was an air conditioning coil added to it. It was a mess. So that's the new space. He cleaned it all up for us, dry locked everything, and gave us a more centralized area. You can see to the left there is the space that is all dirt underneath that little living area, and was a challenge to get stuff in there. It's about half that depth. It just kind of steps up real fast outside of that room. All right. So that's Preston and Cody installing the system. There's a 7 series, and that's the NSW. That's a 2-ton, 100% hot water unit right to the left of Preston with the drill on it that produces all of his hot water in the house. Behind Cody, you can see a flush cart that flushes out the loop field when it's all ready, and Steve's dog, who never leaves anybody alone, especially Cody. So the dog never leaves. So there's a picture of the NSW, the hot water unit with the flow center and the 80-gallon hot water tank, feeding all his domestic hot water. The flow center there is a 2-pump variable speed, has a constant state pump on top of it. and that pump turns on. So the units are slaved so that the small 2-ton unit sends a signal back to the 7 series and tells it to ramp up production of that pump. If that bottom pump, I take that back, Stevie's is different. That bottom pump runs the 7 series all the time. The top pump we have come on when the 2-ton unit needs hot water production. So it'll pull a little bit away from the 7 series when hot water is needed, but not very much. We also, that left-hand picture, you can see we tried something different here, and you can almost see the pump. There's a heat exchanger. There's 4 ports on top of a water furnace hot water tank, and we sold 2 of those ports and piped them into a flat plate heat exchanger and hooked up his existing radiant in-floor tubing under one of his bathrooms to keep his bathroom floor warm, and it worked pretty well. We've done it a couple times since in small areas. We were able to use that. Okay. So that's the unit from the side, everything. You can see the ductwork, we changed around quite a bit. But that gives you a rough idea on size. We had to make that return a little bit bigger to accommodate going both ways. There was no return both ways before. And then the feed was kind of tricky going both ways with that limited crawl space over there. There is the communicating thermostat from water furnace. That runs back to the 7 series, controls everything. Humidity has the outside air sensor on it to control that, which also helps control the auxiliary heat. You can set the auxiliary heat to not come on above or below a certain temperature based on your heat load of the house, really. And then it would save it accidentally coming on if it sees a 4-degree differential, it could accidentally come on. The outside air sensor can prevent that from happening, wasting money that shouldn't be spent. So that's his loop field. You can see where the old boiler sat. That is doubled up at the end. That's just the beginning of it. There's a couple different trenches down through here. He had a fairly good sized backyard for us to keep going. The excavator actually goes all the way, the trench goes all the way down to the left. And then there's a second one that comes back by it. So that gives you a rough idea on size of that trench. I forgot to go back, I'm sorry, on the water furnace, on the communicating thermostat. That thing's hooked up with the Symphony. So I didn't talk about that, I'm sorry. This unit has a Symphony monitoring platform on it, which all 7 series do that are new. A lot of the old ones do too. Allows us to see more stuff here at the office. We can monitor the systems through the winter, summer. We can adjust them from the office, can adjust them from our phone. Allows the customer to see spot on what the unit is doing, how much it's costing to run the unit. If there's something wrong, it sends you an error. Tells us lots of stuff. I have a tendency to look at them way too much, but they're really helpful in finding out what's wrong. We had one last week. We had an open loop system last week that it's aired out twice, and it's down, it's 45 minutes away. And we were able to see from the office that the FP1 sensor was reading 350 degrees, which is impossible. And we grabbed the FP1 sensor, went down and fixed it real quick. Otherwise, you've been going down trying to troubleshoot it all down there, possibly not having the sensor. And it saved us a ton of time by being able to see that right from the office. So that's a really nice feature that it comes with the 7 series units. All right, so there's Stevie's heat load. He was at, where are we on this here? There we go, 53,000, roughly 54,000 BTUs. I was a little nervous on his house with that front room. It's not that big of a house, but it's poorly insulated and the glass was not that well in the front part. His cooling was 33, which is, again, really conservative. That's a high number on that size of a house normally, but again, his insulation just wasn't there. And so that gives a cost of operation on roughly kilowatt hour usage, and should use no electric heat, and his cooling and his hot water consumption. We had nothing to compare that to with him. Oh, this is not good. We've done 2 case studies with the HeatSmart Tompkins. Sorry, hi, Lisa. And I haven't had a comparison on either one of these out of the hundreds and hundreds of systems we have, because Stevie had no idea how much this was costing him, besides costing him tons of time in his cutting of wood. He did have an electric bill for an electric hot water tank, but he was also, we had piped that years ago with a heat exchanger through that for the wood burner. So we really had no good indication of what it would cost to heat his house. And he doesn't even know what it costs right now. I know because I looked at Symphony and see, but he has no idea, besides he's fishing more. So I guess that's overall a huge win. And we are not using the BTUs in that home heating and cooling wise that I had anticipated with what the heat loss came back at. I would say it's closer to a 4-ton heating load and a 2-ton cooling load as a majority of the heating and cooling season. So that was kind of, I can barely see that, sorry. So that shows incentives. This was back when incentives were 30% on the installation, and the NYSERDA rebates were quite a bit higher than they are now. So he had a pretty good rebate. Shows, let's see, system cost after incentives. I didn't really, so we did it based on a rough idea of what it would cost if he'd put a new furnace in there with central air and all that stuff. It's still, this is a tough one to really show anything because we didn't have a good number to go by on payback and all that. But just shows the cost and the rebate and the net system cost. That net system cost right now, I believe, would be about $5,000 or $6,000 more based on current incentives and rebate. And there is a picture of Symphony. So that is what a homeowner sees on their phone or laptop when if they were to log on and see Symphony. So you would see the unit in running. So you had 60, this is not running at the time, sorry. But you had supply air, return air, the loop temperature, auxiliary heats off, compressor, fan speed, humidity level in this home. And then on the side there would give you your energy use and what it is. There is a spot next to that you can click on, the thermostat or your phone, that shows you currently, you can put in your kilowatt hour per usage cent wise, and it will tell you exactly what the cost is to run that per day or month or year. So there is his overall system. Was a little bit cheaper than we had anticipated, but actually I think it's a bunch cheaper because I think that radiant floor was burning up a little more usage on that 2-ton unit than we had anticipated. So I would say he's probably right on with what we guessed by heating with the radiant. Would have been very close. This year obviously is going to be probably cheaper because of the temperatures outside, and this is pretty ridiculous right now what we're seeing. So there's, you can see a graph of his most of his consumption was all December, January, February. The unit very, very rarely jumped up onto second stage, as you can see. I mean, almost never. And once I got him convinced to leave it at a temperature and stop playing with it, it never went back up to second stage again. So it is pretty efficient. There's Stevie standing next to his unit. And he sold his house like last month, and he's building a house that we're putting actually a complete opposite system in with radiant everything. So he's went from a forced air system to a water-to-water system on the new system. And that's still right on top of the unit. You can just see the little white modem. That's the Symphony modem that mounts on top of the unit. So that is Steve. And you guys are gonna, Haley was gonna do the economics and all that stuff, I believe.
So we're going to turn it over to, is Haley here? I saw her. I couldn't hear yet.
Haley, you're probably still on mute.
I see you're unmuted, but we can't hear you.
You want to advance to the next slide and I can start until we can get her on? Thanks. Yeah, so thanks very much, Ryan. We're going to go through the basics of incentives. And at some point, I'm going to hand this off to Haley. We're going to focus on ground source heat pumps because that's what we're really here to talk about. So for the incentive through the utility, NYSEG, this is a full heat load technology. So unlike air source, you don't do a partial house, and it's about $1,500 per 10,000 BTUs of heating capacity. And a very, very rough rule of thumb could be, 45,000 BTUs. So you can do the math. I will hasten to say that everything that's talked about here is illustrative, and the best way to find out what your numbers are is to actually get a free assessment from Dailey Geothermal. Next slide, please. In addition to the incentives from NYSEG, there's a tax incentive, 26% federal tax credit. That is going to go down to 22% after the 31st of this month. So that's something that you might want to consider in terms of moving quicker. You don't actually have to have anything installed prior to the end of the year, but you would need to sign a contract. Next, please. There's financing that Ryan can talk with you about that they use, and obviously there's local banks and credit unions that you all have. So I'll just mention the NYSERDA loans that are available. These are all fixed rate loans with 5, 10, and 15-year terms. For the first, you would actually have to pay for the system in 2020 to get the 26% since it is a tax credit. So it would rely on being on this year. Going back to the loans, the Smart Energy loan and the on-bill recovery loan are up to $25,000. And for both of these, the interest rate you pay depends on your income. If your income is above 200% of median income, and we have those numbers for you, you pay 6.99, and if it's below, it's 3.49. The difference between the Smart Energy and the on-bill loan is the Smart Energy is just a regular unsecured loan. If you were to sell the house, like this client, you'd have to continue to pay on that loan. On-bill recovery is attached to the bill for the meter on the home. And so if you were to sell your home, you can negotiate at sale for them to either take over the debt and just have it keep running, or if you negotiate to pay it off. So you wouldn't have that loan going with you. Finally, there's a companion loan, which is brand new. And this is for folks who, like myself, end up with a cost that's above $25,000. I got a heat pump and I got a lot of insulation. So this is a brand new companion loan. It does have just the 6.99% interest. And this has similar terms to the Smart Energy loan. In other words, it's not on bill. I think Haley may be back with us. Haley, can you test your mic?
You guys hear me?
Yeah. On to the next slide, please.
Sorry about that. Okay, so this is incentive available for low to moderate income folks. So it provides those who apply a discount of up to 50% off their project costs. There's a limit of $5,000 for single family homes, $10,000 for 2 to 4 unit homes. The eligibility has been expanded up to 120% of area median income, and that's through December 31st. And it also includes heat pumps as of December 4th. So those are they're more specific to your income and your home, but we're happy to talk you through any of those specifics offline. Next slide. Oh, Might be having an issue with the slide.
You're clicking the back arrow, Haley, instead of the next slide arrow. There you go.
Awesome. Okay, so then we have the low to moderate income adder incentive. So this covers projects up to 60,000 BTUs. This is also as of December 4th. It's available to homeowners under the 80% of area median income, but it's only for 1 to 4 unit residential homes. Also, it doesn't apply to non-natural gas homes, and you must have insulation. And it can be stacked with other incentives. So this is like a lot of information. Something else I would recommend talking to us offline about your specific situation. Next slide, please. Okay, so now we're to the process for you participating. I recommend, one of the biggest questions we get, or the number one question we always get, is how much is this going to cost me to do? And so what I would recommend is that you fill out the assessment on our website, newyorknest.org, and then we can get you hooked up with an installer, and they can let you know exactly how much it will cost you, and that's free of charge. And then say you're happy with it, you think that the savings are really going to be there for you, you would sign a contract for your desired system, and then you'd apply for the incentives and financing if you qualify for them. And then we get the installation work done. Next slide. So then during this section, we'll be leading a Q&A. So you can do this in 2 ways. You can put your questions in the chat, or you can unmute yourself and ask your questions directly. We have Adam, who's our program director, and then we also have Ryan Dailey on the line, who can answer specific questions about Geo.
Thanks, Haley. And you probably ought to mute. It sounds like there's a lot of background noise. Yeah, so I see the beginning of a question here. Oh, yeah, from William J. Rigby Co. If you want to just unmute and ask your question, that would be fine as well. All right, then let's go to any other people that would like to ask a question.
There's a question in the chat. AirCheck asked, can geothermal be used for hot water heating, not instead of forced air? In other words, I think heating the whole house with hot water is what the question, what AirCheck was asking, I believe.
Yeah, I think Ryan's got it.
Yeah, absolutely. There's lots of ways. The hydronics water offers way more options for heating.
Ryan, why don't you tell the folks a little bit more about that? Because I think people get very confused about this question, and they also wonder how they could get cooling too.
So, I mean, forced air is forced air. You have a duct system, blows it around, hot, cold, end of the story. Water to water, you're producing either chilled water or hot water, and you can deliver that to any means of distribution. You can deliver it to an air handler, which hooks up to a duct system and blows around. You can hook it up to where you see air source heat pumps. You have multi-aquas up on the ceiling, or console units mounted high or low. You can do the same thing with Geo. You run cold water or hot water to them, and Adam has some of those in his house. You can do radiant in-floor tubing. You can do, what else is there? You can do hot water baseboard. You can still tie in old steam units if you had them and run hot water through those, and then supplement them with a forced air of some sort to supplement that you can't get 180 degrees out of the water. And then that also gives you your cooling, which you just are reversing the unit and producing cold water and flowing that through the units, and having hot water or cold water wherever you need. Easier to also do 100%. Oh, can everybody hear me okay?
Yep, you're coming through fine. We've got a couple of questions here. from William Rigby, and then a couple of questions from Judith. For the first, you said the life of the system was 20 to 25 years. What part of the system is usually in need of replacement after that point? And the second is, what is the cost of electricity? We have NYSEG, which is expensive. Is it viable for us?
So the life of the system, 20, 25 years. Most units come with 10 years parts and labor. Long-term wise, you're going to see normal failure parts would be pumps, small things like that you would see on any common, whether it be conventional baseboard, hot water, forced air, anything, you're going to see pumps go. The compressor should last the longest, and that's the biggest part of the system. Blowers, it's all electrically driven. Anything can fail. So they, 20, 25 years should be an overall, the heat exchangers, the coils, all that stuff should last that long if properly maintained and done with. That's a tough one to really say on what usually needs replacing, because what it is that we've had any issues with have been small things, sensors. We've got bad batches of sensors and had to replace 70 of them at a time because a $10 sensor came bad. But overall, very few failure parts do you see in that time frame.
And then the second question was regarding the cost of electricity. NYSEG is actually a lot cheaper than most utilities in the state. And while your cost increase for electricity will definitely increase, if you're currently heating with fuel oil or kerosene, there's no question that your costs will go down. I don't know if you want to add something to that, Ryan.
Well, that cost difference is if you went back to that slide when I said, or when we looked at it and the overall cost was like $850, that's your electric bill going up. That additional $850 would be your difference between, if your propane bill was $2,500, you get a $1,300 difference in the two of them is what your savings actually is. So your electric bill is definitely going to go up. But like I said, your cost running with NYSEG is pretty cheap. Downstate, the incentives are much higher than they are down here because electricity consumption is much more downstate. But yeah, that's that printout and what you see consumption wise is that's your cost. That's your electricity cost is your heating bill for the year. That one above it, Adam, is a question. Yes, it is. Geo's no problem to put in that situation. It is definitely more expensive to install radiant, tear out a duct system and install radiant than it is to tie onto an existing duct system and heat that house much more.
And there's another question. Is there a way to take advantage of the current incentives despite not having taken ownership of the property?
Ooh, I don't know about that one.
Yeah. I would lean towards no. I think, one issue is that the incentives are through NYSEG, and if the bill isn't in your name, my suspicion is you wouldn't be able to do that. That is not one that I'm 100% certain of, but we can check in on that and get back to you. But my suspicion is that would not work. So we don't have any other questions in the chat. Could you talk a little bit more about your install in terms of what I guess is the more common install that you illustrated this time, which is using existing air ducts? Does anything come up when you're converting from a conventional furnace to a ground source heat pump in terms of basically plugging and playing with those ducts?
Yeah, most of the time it's a return issue. There's almost never returns properly done on furnaces, and you got to have a huge return. That's the biggest thing with Geo is it's not, forced air systems are based on BTUs. So if you size ductwork to move a certain amount of BTUs, pretty close to half the size of what's normally run for geothermal. So geo, we run it based on CFMs. So 400 CFMs of ductwork is way more than you would need to move 400 CFMs of air in a conventional forced air system. So a duct system and a geo system is way bigger than a duct system on a conventional furnace with a air conditioning coil and stuff. Generally, with the 7 series, you can play around with that a little bit more and not have to tear full duct systems out and redo them, because if you put in a 5-ton unit and you have to get rid of that 5 tons. If you put in a 7 series with a 5-ton unit, you can slow the blower speed down and you can play with things inside of that because it's variable to match up maybe not a 5-ton capacity size duct system, but almost always we have to add a couple runs and fix the returns. We just figure that it's happening on every system.
Great. Judith has another question relating to radiant heat. And I'll ask this question, but you might want to expand on some of the scenarios with radiant. She's asking, do all the floors need to be ripped out for that?
No, they do not. Normally, as long as you can get to them from underneath, you can heat it with heat transfer plates. With radiant, the whole key is running the water temperatures as low as you possibly can to heat the house comfortably. So it's all based on outdoor reset, and we use a TechMark controller and build this control box that allows you to play with the house. An old house, let's say you get an old farmhouse, you're going to need more temperature to get through thicker floors and so on and so forth. Newer homes, you're going to be able to run that temperature probably 20 degrees cooler than you need. The common mindset has always been, you need 120 degrees to get through floors, and you need 130 degrees to get through thicker floors, and you need 140 degrees to get through carpet. That's not true. If you actually play with the house and learn what it actually needs, you may be able to get that temperature down to 95 or 100 on a non-design day of, let's say, 35, 40 degrees outside. You do not need 120 degree water. You end up overshooting the house and it becomes too hot. You have floor sensors and other things. But if you can pick this temperature, let's say 60, and then 0 is the bottom end, and you pick your middle temperature, you can fluctuate that water temperature to meet the needs of the home, keep it more comfortable and save money because you're not needing to run the compressor as much to run 130 degree water. If you look at all the manuals and how geothermal has been done for years, it's always been with this buffer tank on the side. Adam, this is how your house is. And you just pick a temperature, you heat that buffer tank to that temperature. Terribly inefficient, because you're just wasting this energy in this buffer tank that doesn't need to be there. It's not going into the home, it's not going into the load. So if you pipe it differently and control it differently, you can make the water to water become more efficient, close to a 7 series, not quite that efficient, but you can get it so that it's fairly close efficiency wise. It just takes a lot of control work to do it.
So the bottom line is, no, the floors don't need to be ripped out, usually, as long as you can get to the underside and put in the plates, and then the rest is a bonus. Other questions?
The plates are the key with radiant.
So I know that sometimes people are going to wonder about what it's like in terms of the time scale of all of this, particularly at this time of year. Let's say that sorry about that. Let's say that I was to sign a contract with you today. Sort of what's the staging of things? And I know that it's variable depending on what you're doing, right? Obviously, if you have to do major modifications to the distribution system, that takes more time. If it's a well versus trenches, but maybe talk through that a little bit.
So now we try to, if someone calls now and wanted a system, we couldn't put it in till February-ish. But we would try to get the loop in as soon as possible so that part was done before it got real cold. It's still no problem digging. So let's see, the people that I've talked to in the last week, if they called back today and said, hey, we want to put the system in, we would figure out a way to try to get the loop in just as fast as possible and then work around the heating system when that came. Usually we have to figure out some way we have temporary hot water tanks because we pull, whatever your hot water is, the temp tank goes in fast. And then heating wise, we try to limit it as little as possible. Sometimes you can get the auxiliary heat on in a day. And then you got a little bit of play to do that. Water to water, it's a lot harder to tear out and put back in the middle of the winter, but it can be done.
Great. So we can still take a question or two, but Ellie, if you can put up the slide for our contact information and then the one about future webinars. Just want to remind folks that the first step in this process is getting an assessment, and that's free. So to do that, you go to our website at nynest.org. And our next program, so it's coming up here. Our next program is actually going to be next week. I believe it's on the 9th. Yeah, here's our contact information, our phone number, email, and do like us on our socials. We'd love to see you there. We put all our information up, so programs are announced, and we've had some stuff talking about the staff and the interns and a little bit about us and so forth. You want to go to the slide with the dates? Yeah, so next week, we're going to have the Installation Man, our home performance partner, is going to do a virtual home tour. And we're actually going to have the homeowner as part of the presentation. It's a home here in the city of Binghamton. So that's Wednesday the 9th from 12 to 12:50. And then in the new year, we have two more events. One is on the 13th at 7 p.m. and that is one of our general programs. So that will include all of our partners, in addition to Dailey, who's here with us today, and the Installation Man will be with us next week. We'll also have Dave Chernow from AirSource LLC. So you get to hear from all the contractors and hear a little bit about all the different technologies. And then later in January, on the 21st, we're going to have a virtual home tour featuring AirSource heat pumps in Oxford. And Lisa is mentioning, which I thought we had talked about, but I'll just do it now just in case. There is a pilot study on top of the two low and moderate income programs on top of Empower and Assisted Home Performance. And NYSERDA will end up paying for all or most of your heat pump installation at that point, because you'll qualify for the NYSERDA incentive, provided you are a NYSEG customer. That's important. If you live in a muni, you can't take those. And you'll also get the Empower or the Assisted Home Performance incentive, and then there's a significant amount on top of that. So that's definitely something to look into. If you think you may qualify, I know that this is rather complex. You should feel free to reach out to us to discuss that part of the financing. But as Ryan indicated, they have a lot of work right now. So the sooner you sign up, the sooner you're going to get in the queue to find out whether geothermal is right for you.
This is a great
So,
program from NYSERDA, but
I'm sorry?
I said I love that this is a great program that NYSERDA has thought about. But I struggle to find any contractors that have openings in the next 30 days to install heat pumps.
Well, they don't need to have an opening in the next 30 days.
Yeah, so the thing,
That's
yeah, it's not the study that's going to expire. What's going to expire is the increased income level for assisted home performance is going to expire. And Lisa tells me that the level of awards for empowered and assisted home performance are going to go down as well. But the study will continue on until the money is gone. So basically, if you are qualifying for assisted home performance or Empower in the new year, you can use that study. You can use it now.
And as long
Any-
as you have applied for assisted home performance before the end of the year, then you're in for next year. You don't have to have signed a contract. You don't have to have, you don't have to have anything installed. You just have to have your application in.
And I'm going to mention one other thing. We've been focusing entirely on residential, but I discovered that if, for example, you have a church or another small commercial property, there is still 0% finance money out there from NYSERDA available that has not been spent. Maybe you're here because you're interested in your house, but maybe you worship at a very leaky old church, like one we're working with in Tioga County, and that might be something you want to look at. And it's possible now with that additional loan to go up to $50,000, and so it's a pretty good deal. I'll take one more question if there is one, and I see Ellie saying I'm breaking. Good now. Okay. All right, and from Dailey Electric, Dailey Geothermal, for joining us. They've been great partners, and look forward to working with them ongoing into the new year. And I want to thank my team, Ellie, who you've seen, Olivia, who's been running the tech behind the scenes, and the director of this program, Haley. Do join us again for our future programs. And again, if you want to reach out to us, nynest.org, info@nys.org, or 873-9220. Thanks, and have a great afternoon.
Bye, guys.